Okay, I think we can get started. Welcome everyone. My name is Wacker. This is the Automating Security for the Cloud talk. And I think as most of us here are security professionals, there's a lot of pieces that are relevant to really everything that we do. I work for a company called Cloud Passage. We secure virtual machines running in public and private clouds. And I'm excited to be here today to share what I've learned really when it comes to understanding the differences in architecture for security in the cloud, the differences in operations, and the differences in organizations, which is one of the most interesting challenges that we have to face. Really appreciate everyone voted for this session. It really makes it all the more special to be up amongst peers that were interested in hearing what we have to talk about. So let's go ahead and get into it. I'm not going to spend a lot of time on my bio, but I am curious, and even though I can barely see folks thanks to the lights, how many folks view them as security operations teams? I believe they're on security operations teams. Oh, thank you. I could see a little bit. A little bit? Only a couple hands? What about IT operations teams? How many folks are on IT side? Okay. Anyone here view them as part of a DevOps team, if you've heard of that term? Actually, most. That's excellent. Well, the talk was subtitled "How to Get DevOps to Love Security," so we'll talk a little bit about that. What I want to do really is hopefully educate folks on some of the subtle and not so subtle differences between doing security in cloud, particularly public cloud, infrastructure as a service, versus doing security on-prem in a private data center. And one of the first places that you really have to look at that is who's actually running servers in those environments and what their motivations are, and whether or not they care about security and what they're doing. We'll talk about the architectural differences, why your current security toolbox does not work in public cloud, even in private cloud. And we'll talk about the DevOps versus SecOps, the meat of this conversation, and really how do we make sure that what a really innovative group that's building new services online, how we can keep that safe and prevent some type of backlash against the adoption of cloud due to security FUD or concerns or those kinds of things. So let's start really and talk about who's running in the cloud. And that's one of the reasons that I surveyed everyone at the beginning, was because in many cases, folks who are running services in the cloud are not necessarily folks that are used to running services on-prem. The public cloud especially has made the barrier to entry so low that almost anyone who has a problem to solve and a job to get done can go and swipe a credit card and spin up a server. And that has a lot of implications for security, because in the past, there have been a number of checks and balances that people have had to go through in order to have new servers provisioned and in order to have new systems brought online. But the problem is that even if a IT security server admin has an understanding that they need to worry about security when they move a service to the cloud, sometimes the case is that they don't have the time or the luxury to do that. And if, for example, they need to stand up a new service and their own internal IT group can't do it fast enough, they may just go ahead and rent something out there and expense it just to solve their problem of the day. This gets even worse when you start talking about people who aren't IT focused at all, but are purely focused on their business problem. And big data is another example. I think it's really interesting how many big data people are leasing servers in the cloud, because instead of building out a data center of 500 bare metal servers, they can go and just temporarily lease that time, at much lower cost and much lower operational overhead. But these folks, since they have a need to solve a specific problem for analysis or analytics or something, are not thinking about the security implications. And that puts their organization at risk without anyone necessarily knowing about it. My favorite operator in the cloud, though, is DevOps. And if you're not following DevOps Borat on Twitter, you should. He's as good as Drunk Hulk or better. I'll talk a little bit more about DevOps in a little bit, but our goal here today is to figure out how can we turn this guy into someone who loves security and knows what he needs to be aware of when he's tilting up new services. And I'm sure folks are pretty familiar by now, what people are using the cloud for, and there's a longer list even than this. But three major use cases that we as IT professionals need to be aware of It's very common, very, very common for people to be using the cloud for temporary development resources. Someone needs a new server, they got to get a job done, it's going to take too long for IT to spin it up. A lot of people are building permanent applications in the cloud. Can't name, I cannot name the number of companies within an 8-block radius of this building in this area that are building brand new web services I'm sure that you're all using that are based entirely in the cloud. And then the temporary workloads, like I talked about for the big data analysis, those kinds of things, is really interesting use case and fits that cloud operational model really, really well. For the benefit of everyone here, it's a bit of a cliche to say, but the truth is that very often people don't know their organization is running cloud servers and that they're at risk until they do something as simple as look at expense reports. It's sad to say, but there are various people out there in very large organizations who finally realize it's probably not likely that someone's buying $1,000 of books every month. There's something else going on. And for all of us in this room, if we're responsible for security for an organization, we need to keep that in mind. I'm used to wandering around. Being rooted at the podium is interesting. So let's talk about why security in the cloud is different. Because we all have a specific set of tools that we're used to using. And the more that I've learned about security in the cloud, the more that my coworkers have learned about security in the cloud, and we have a long history of security experience, the more we've realized that the architecture is so completely different that we just really need to rethink the way we're doing security. So in the simplest case, let's think about what we've done before, where you have a private data center with a set of perimeter protections and protections inside that keep the bad guys out. And because of that, we have, over time, let our posture inside the data centers degrade. I can't name how many servers I've run personally in a data center where I've let non-core OS packages get out of date because, hey, no one's going to be able to connect to that port anyway. Or I know all the people that are going to be able to log on here because I'm behind a Bastion server, or those kinds of things. So, frankly, we've gotten lazy. And that's okay because the architecture allowed us to do that. But what happens when you're in the cloud and all of a sudden you move one of those servers out into public cloud where you really don't have any of those same protections? In fact, you have none of your company's data center protections available to you in the cloud just because it's hosted in someone else's data center completely. And so this is where taking a server as it is today or any kind of service and putting it out in the public cloud puts people at the most risk. Because then attackers are out there looking for at-risk servers, and we see this happening every day, where those servers are getting compromised and used for various nefarious purposes. But it's not just as cut and dry as that. The other problem is that security in the cloud is very, very complex. You move a server from private into a public cloud because you want operational efficiencies and you want to make it easier to do things like scale out. You want to make it easy to scale back and cut your costs back if you don't have so much load. You want to be able to move between clouds to take advantage of the cheapest hourly costs and those kinds of things. Having spent 15 years building traditional network security products, these are the kinds of use cases we never considered when we built firewall management tools and those kinds of things. Because frankly, the idea of a dynamic IP address, a server that may go dark and then come back online in a completely different data center, was not something that was common, if at all, happened in traditional security management. But the truth is that the attackers are out there, and we've seen plenty of evidence of that. For example, the Sony breach last year, part of it was launched from Amazon. And these things, there are people who are actively scanning servers in these cloud providers looking for vulnerabilities. So traditional security products just simply aren't adapting. And it's not that there's anything wrong with them. I think that there's a ton of traditional security out there that's important in all environments. But the traditional products are not able to deal with the temporary and elastic deployments, the metered usage where people are paying essentially by the hour, or multiple cloud environments in that dynamic environment. And so that causes risk and it causes concern. And frankly, at this point, most surveys about cloud adoption rate security as the #1 barrier. where people are saying that I'm not going to move to the cloud until I've addressed the security concerns and I can feel comfortable with it. So we actually drilled into it a little bit more. We were curious, what is it about security that you care about? And we did a survey of hundreds of IT professionals and got back a very interesting set of parameters. Lack of perimeter defenses and or network controls. I don't have my firewalls, I don't have my border gateways. That's concern, as what it should be. Multi-tenancy, that's something that people are going to have to start to realize that they'll need to figure out how to get comfortable with in a cloud environment. Compliance standards, obviously. Enterprise security tools don't work, obviously. This one's very interesting. Provider access to guest servers is, I think, one of the new dynamic areas in the public cloud that a lot of folks aren't used to. There are many service providers that require you to give them access to your server for various maintenance and operational purposes. Even if they don't require an account or a login on your machine, they have access to the servers that are running in the hypervisor. If anyone remembers the Amazon rolling reboot from back in December, that was because Amazon patched your servers by going in and actually changing the drivers from under the covers, and then they required you to reboot to take advantage of that. So it's not a bad thing. This is awesome because people are able to do this kind of thing automatically, but it requires us to think differently about our operational model and about our security model for doing these things. Okay, what about the fine print? Who here has actually read the fine print for your cloud provider? When it comes to security, they will all tell you very explicitly, and they're actually very good about this, telling you that the responsibility for security is shared between yourself and the cloud provider. And so they are responsible for everything from the physical layer, the network, the compute, the hypervisor. You are responsible from everything above that. And Amazon will say, they're one of the best when it comes to making this explicit, that the customer should assume responsibility of the management of the operating system and all the data there. And they recommend that it's possible to enhance security of those systems by deploying host-based firewalls, host-based intrusion detection, those kinds of things. And this is an important concept because we come back to it in the way that you can secure based on what you actually have control over. The problem is the people who are running servers in the cloud, those IT folks that need to get something done, the big data folks, they don't read this fine print and they don't know that they're at risk. And in the old days, it wouldn't be a problem because they'd be requesting a server from IT and they would go through the proper security pieces. But if you ask any business analyst, what are you doing about each of the different slices of security that you traditionally have in your private data center, their head's going to spin and they're not really concerned or thinking about these things. But again, the barrier to entry is so low that someone can swipe a credit card or even get a cloud server for free these days to run and play with and those kinds of things. And you won't know that as a security professional in your organization, and that will put you at risk. Another question in the survey we ran specifically was about who is responsible for securing those cloud servers. And this highlights a lot of the confusion out there. We're not securing our cloud servers. Okay, at least they're upfront about it. That's good. Hearing that their provider does it for them, that's worrisome because, as we just saw, they're not. Dealing with open source tools, having a manual checklist, those kinds of things, those things are good, but it's not taking you all the way. And we need to think about how do we actually create new tools that operate well in this cloud environment. Because we are all at risk, because we know that there are scans going on, people looking for compromised servers, those kinds of things. And for anyone who's questioning it, go look at the SSH logs on your cloud server. I can guarantee you people are trying to brute force that right now. So, here's where we get to the part of the talk, how I learned to stop worrying and get DevOps to love security. Who here knows what DevOps means? Okay, great. Gentlemen up front. So, DevOps is it's an emerging term. In the past, it's been called automation engineers, systems engineers, people who keep the site running, but also have a big part in actually building the site and keeping the site reliable and those kinds of things. So something I've done in the past very often, where you're the only person out there that's responsible for what you're building. And it's the popular term right now, but honestly, the cloud has made it very easy for people to build awesome new services with very little organizational structure. You don't need an IT team and a programming team and a QA team. It can all be the same group that's making things happen. Unfortunately, they're separate from security operations. There's very rarely a security slant on these teams, and that causes a problem. But the question is, why is DevOps a popular term now? What is it about the cloud that they really love for getting their job done? And that's simple. It is easy. The cloud is so simple to spin up a new server. Bam. Bring down some servers. Bam. Install a whole bunch, build a whole bunch of new machines through some scripting or recipe kind of thing. Bam, hit the button. So people who have tried to automate security in the world free from physical machines love infrastructure as a service, either public or private, because they can just go and automate and script creation of servers, bringing up of servers, bringing down of servers, putting new software on servers, those kinds of things. But the challenge for us is that we have different goals in our jobs. So the DevOps folks are building stuff. And I give a shout out to our community manager up in the audience. She had a great example of this, where the security people are looking at solving puzzles, and they're trying to figure out how things work. As a security person, this foundation would drive me nuts. I could see that falling down in a second. I could not handle that kind of piece. I'm much more interested in figuring out how do we make that entire structure safe, and how do we make sure that it's running in a good environment. But for the DevOps folks, that's not what they're thinking. They're thinking, how do I keep things running? And they love the cloud because they are sick of waiting for slow IT operations services in order to bring things up. So let's do an example. So, coder Hank is trying to tilt up a new service, and so he's waiting for server provisioning. So, he files a ticket, someone picks it up, they get the information, maybe they got the server in stock, maybe they don't. Eventually they roll in some new boxes. But they're not done. And so DB admin Dean is out there waiting for the firewall updates. Because until you actually update those policies, those new app servers can't talk to the database servers. And so, provisioning of a few machines like this in a traditional data center, how long does that take? Days, weeks, months sometimes? On average, it's about 6 weeks. Whereas someone who has, an automated infrastructure as a service login can do it in about 6 minutes. So you can see why people are really interested in this model. But when something goes wrong, say there's a server crash or there's an issue on the site, okay, now they're worried. They're going to go make some tweak on that app server that they're not going to tell you about. They're not going to go back and reset. They'll maybe change, SSH logins or something like that. That's when the bad guys get in, compromise that server, and the reason we have these two-layer networks is because if they've compromised the front-end server and the DMZ, we don't want them getting back to the database server. So the traditional data center architecture has kept us safe to a degree, even though it's slowed down business and operations. You move this out to the cloud, all that goes away. All these servers are now basically sitting naked in the sky, and you have to be really worried about what goes on. So what do you do? So this is the hopefully educational part for folks that are responsible for securing servers in the cloud. First off, you've got all these servers in the cloud. You need to make sure that those servers are always up to date. You need to make sure that you always have all of the patches, that you always have the right configurations on those servers, and you need to do that religiously, probably twice a day. Vulnerabilities are published so quickly, things change so fast, that if you're waiting once a week to do a system update, you will get compromised. And believe me, there are people out there trying to compromise your servers in the cloud right now. The other thing you're going to do is you're going to think, okay, so I've got these servers there, they need to be secure. I'm going to put firewalls on. Host-based firewalls work great. I can make a little script that starts that up, and I can communicate between these servers. That makes a lot of sense. But think about the cloud operational model. Think about what happens when you add a new app server. that has to talk to the load balancers in the database server. Think about when you add new load balancers, new database slaves, all these things make it essentially an exponential set of relationships you have to maintain for those firewall connections. And that's very, very complicated, and it's something we never had to deal with in the past. When you had a single choke point firewall or maybe 2 layers with the DMZ, you knew what was in back of it, you knew what was in front of it, and you set those connections in a very static way. Right now, these servers will be here, one of them will go down. Very common, servers in the cloud crash or they get taken down, those kinds of things. That IP address gets recycled very, very quickly. And it is very common for an attacker to jump in, look at that IP address, and immediately scan every server around them looking for vulnerabilities. And this is very, very common how people are getting compromised in the cloud. You have to be aware of it. So how do you deal with something where you don't own everything? How do you secure something where there's no steady state, there's no static IPs, those kinds of things? How do you handle the variable workloads? How do you make sure that your system's not bogging down and costing your company a lot more? Because in the cloud, you are paying by CPU cycle effectively. And how do you make sure that this works not just in public cloud, but also back in your private data center? Because if you're taking advantage of public cloud right now, you will eventually hit the cost curve where it's cheaper to bring some of your servers in-house, and you will soon be operating in a hybrid environment. So our tools are broken, everyone hates us, now what? So gratitude to the memes out there, but frankly, we got to secure all the VMs. It's really about what is the one thing that you can control, what is the one thing that you can secure, and how do you keep that under lock and key so that you can still take advantage of the operational models of the cloud and give the DevOps folks what they want, but you make sure that those things remain safe. So my thesis is that you have to focus on the VM. We are moving back to a world of host-based security because, frankly, you don't have access to the network, so you can't do network-based security. So we have to think about host-based security, and we have to think about doing that in a way that handles the dynamic nature of the cloud. It's not just, an agent that runs here that's always going to be that same agent on that same server. You need to realize that the VM that you can control is the thing that's going to get cloned. And so if it's scaling out in your public cloud, or it's the thing that's going to move, if it's moving from the private cloud, from the public cloud into your private cloud, doing something hybrid, the VM is the only thing that you can count on controlling in all of these environments. And so that's really where you have to focus your efforts when it comes to security. So in the cloud environment, for folks on the video maybe don't see all the details, the intersection of control, portability, and scale is always the guest virtual machine. And it's painful to a lot of security people in the past who tried to stay as far away from the machine as possible, but it's what we're going to have to do. So what do you do? So what you need to think about is look at that stack. Got a virtual machine, so can't even touch the hypervisor. Remember, we are not even able to touch the hypervisor in public cloud. So you've got to focus on the OS, the Linux distribution, your Windows server out there, and there are lots of Windows servers out there. And you got to worry about securing the OS. Make sure that all of the software is up to date. Make sure that its configurations are locked down. Make sure that if people don't change it, or that if they do change it, that you know it and you can change it back immediately. That requires extreme diligence on the part of the security team. You're going to have to add host-based firewalls. Like, no two ways about it. Even though, for example, some of the, so Amazon's an example that has a inbound only firewall of security groups, not PCI compliant, doesn't work across multiple Amazon clouds in the different regions, those kinds of things. You're going to have to add and maintain host-based firewalls. You're going to have to watch and make sure the application stacks are up to date. I can't tell you how many people I've talked to that their entire company has gotten compromised because someone found a vulnerable WordPress server. It's very, very painful, but it's very, very common because someone in marketing, hands up, I'm in marketing, someone in marketing went and actually put in a WordPress server that then was popped, and then they were able to get inside the private data center from there. Watch the application code. So beyond verification of what the developers are putting out there and doing your penetration testing on those, make sure that code doesn't change. Verify the integrity of the source files and everything that's going on in your stack, because it's a very dynamic environment and you can't always be sure that someone hasn't made a backdoor without you knowing. And then obviously track the sensitive data and prevent egress. So you have to think about all these layers, but now you have to do it from inside the virtual machine as opposed to outside, which is what every network-based, hypervisor-based solution has ever done, and those just don't work in public cloud. But the challenge now is you have to automate it. It's not something that you can just fire and forget and put pieces on there. You have to build out a system that's going to fully automate all these pieces, because those servers are going to get replicated over and over and over. I was debating with myself last night how many times I should replicate this out, but I tell you, I have seen people that have one gold master server and they have spawned 1,000 clones of that. The original bug that was on that one master server, the original misconfiguration, extended through all those 1,000 servers. And the bad guys love that, because if they can compromise one of the early model versions of that, then they're going to have their Trojan on every single clone that gets created. But you also have to do this separate from the actual server operations, because I can tell you the people who are building the sites, the people who are running the services, are not going to stand for them having to take care of security responsibility or for you getting in their ways on pieces. So you have to figure out, how can the DevOps team still have access to all the application code, modify the frameworks, all those kinds of things, but how can you on the security team keep track and management of all the different pieces that go into keeping that system secure? So that's really the high-level ideas of what you need to do in the cloud. And hopefully, after all that, you end up with this guy. You know, someone who's really, really happy that there's a really strong team watching their security. I heard someone says, want that shirt. We'll have to take a note of that and make some of those. That'd be good. So I'm ahead of time here, which is good, because I'm hoping there'll be lots of Q&A and discussion. And I was told there had to be one cat in every single presentation. So is that okay? So, who here is responsible for securing cloud servers to some degree? Yes, good amount of people. So that is, what we all have to keep in mind is that you have to defend those VMs, you have to automate all of that security, and you have to worry about the firewall controls. You have to worry about the vulnerabilities in the software, the configurations. You have to worry about the integrity of your code. You have to worry about who's accessing those servers. And here's the graduate level course. You have to figure out how to automate and integrate all that into your on-premise security systems, which becomes even more complicated if you have compliance needs, for example. So it's not an easy problem. A few tips, though, that I think that's really important. So you do need to realize, even if you didn't raise your hand, there are people in your organization using the cloud. And they don't understand security, and they do not know their responsibility. So for every single person here, go back to your organization, your company, even just your team, figure out who's running stuff in the cloud, and make sure that people are aware of these complications, because otherwise your company is going to get in trouble. The cloud's actually going to probably take a black eye as some major compromises happen out there. And people just don't understand the difference. But, as we mentioned, the bad guys know this. So the risks are out there, and the risks are great, and we need to worry about it. So think about, how can you leverage that new architecture? How do you actually take advantage of the restrictions in many ways to create a new and possibly even more secure environment out there? So know who's running what, go and find them. Read and understand what your provider does. There are providers out there that do some security pieces, but they will be very explicit that they don't do a lot of the stuff that I'm talking about. Be very, very careful if you're going to take an existing server and move it externally. That's probably one of the biggest problems where people get into the most trouble. If you start with a server you built in the cloud, at least you're starting from a fresh image. If you take an old, crufty server out of your private data center and move it into the cloud, that's where things really start to worry. But here's the best one, and I think that, and someone else had said this, and it just really makes sense, that if you've got to figure out how to use cloud, and you're going to, start with the public cloud. Because due to the restrictions, the fact you don't have hypervisor access, you don't have network access, once you solve the problems of how to secure the public cloud, everything else is easy. You can move those systems back inside, you can do hybrid, all these things, you can move providers. So find the most restrictive environment that you have to solve the problems for and start there, and then it's going to be really easy to do all of your future cool stuff. And focus on what you can secure and what you can control. So we're going to have tons of Q&A. I do want to call out that we will post these slides on community.cloudpassage.com. Hope to engage folks in conversation there. I'm available on Twitter, going to be here at the show next door, going to be here all day tomorrow. And we're hiring. We're looking for security and cloud experts and really interested in talking to folks. So I'll leave this here and see, does anyone have any questions? Please, we're going to need to use the mic so that folks on the stream can hear it.
You mentioned that when a server goes down or a VM goes down in the cloud, that IP is reassigned, and you seem to say that's a point where hackers could jump in. I didn't understand what would allow them to do something that they couldn't do before just because the IP is free for a moment or reassigned.
Great question. So I'll actually skip back to that slide specifically. Okay, so if one of your servers crashes, or even if you just take it down, so again, the dynamic nature of the cloud, you're scaling up, you're scaling back all the time. When you take that server down in the public cloud, the IP pool is shared. In your private data center, no one can have access to that IP except for you. But in the public cloud, that IP address will be recycled and reassigned to essentially the next VM that comes up. There's no distinction in this cloud. You know, the green, blue, and dark blue servers may be yours, but there's no distinction of the thousands of other servers that are running in that same cloud in the same subnet. And so it's very common, and we have seen it, where an attacker, as soon as their new server comes up, they'll actually cycle through requesting new servers constantly. As soon as they get a new IP, they'll scan in an outward motion all the servers that are near them, looking for open ports that were open to that IP address that just went down. Does that make sense? So that your server's going down, and you're taking it down, and then they're sneaking in there trying to take advantage of those open firewall ports, which you've done the right thing. You've secured your servers, and everyone thinks about, this is where everyone gets tripped up, because they think, oh, I can automate my firewall table rules and just tell my orchestration system, new servers built up, I need to add that rule in. But they don't think about when servers go down. And more importantly, they don't think about closing that port up within seconds of when that server went down. So, please. Yeah, quick follow-up, and then we'll move on to other questions.
So can I create a service level agreement that says I must have just this range of IPs, and you can never give that to anybody else? Is that ever done so I could prevent this?
You can request a specific block. You can actually request a private cloud, and you'll pay through the nose for it. So yes, you can do something like that. It's like running in a private data center, and you'll pay through the nose for it. So, yes, question, Mike.
Thank you. So all your blue connections here, they're kind of, if you move stuff from your private data center to the cloud, in the private data center, people kind of use not encrypted connections between machines.
Mm-hmm.
I think everybody should actually know that they should now use between those firewalls encrypted connections or SSL tunnels.
Yeah.
Because so if a connection comes in and the app server went down basically and comes into the database server, which is open basically in a port, there could be a service application level attack on that port, and everybody needs to know that everything needs to have a kind of a secure tunnel here. It's just a comment, not a question.
It's a great comment. I'll follow on with that. So his point is that your traffic is fairly exposed here, and you need to make sure that you're encrypting the actual data going over that piece. And that's a great second step. You also need to make sure that when, for example, your app server is trying to talk to your load balancer, that they're authenticating they're both the right people. Because you don't have control over the IPs, which has been traditionally how we've identified what servers can talk to what servers, and these change, and so now you're moving to much more of a machine type. policy and group-based enforcement. Thank you. Great comment. Others, please. Yes.
So, could you speak briefly to the advantages or disadvantages between building in ongoing patching on an instance, like persistent patching and updates on an instance, versus doing that patching on the gold master, and then just simply destroying instances and creating a new copy?
Great question. So you've obviously got some experience running servers in the cloud. So what this gentleman just described, I don't have a slide for, but maybe I can demonstrate through interpretive dance. Patching in the cloud is kind of is something that's becoming passé. There are a lot of people out there, some of the most advanced cloud-using companies will say that they never log into a machine and patch it, because what they're doing basically is they've got a gold master that they keep up to date, and instead of patching running servers, they'll just knock those servers down and create a new server from the gold master image. Is that the model that you've seen?
Yeah, that's the model. I'm wondering, what's the advantage of doing one way or the other, because there are trade-offs.
Right. So his question was, what's the advantage of doing it one way or the other because there are trade-offs? So off the top of my head, one thing I've seen is that it's never taking down your entire fleet and restarting from scratch. So if you've got a big security issue, you put that in, or it's not even a big security issue. If you've got a normal patch, you'll put that in your gold master image, and then just week by week, old servers will age out and new servers will come in. Again, bouncing your entire fleet, that's a big deal, and people don't do that regularly. So one risk is that you will have a very up-to-date gold master image. You'll have some very up-to-date, very secure, instances that were just launched this week. But you're going to have some that were launched 2 weeks ago that are a little bit crufty, 3 weeks ago, that kind of thing. I dare you to categorize all the software running on and all the versions running on all those versions, and know, if an exploit just came out, is it still possibly, even though it's not on your gold master, is it still possibly out there? So it's absolutely the operational model that I think people are moving to, and the idea of doing, live patching of servers as they're running is becoming, as I said, passé. But the truth is that you still have to be very operationally aware of what's running so that you can prevent those types of compromises. Great question. Questions, comments, insights? Clear as mud? I don't know if you want to come down for the mic, or we can reach up there.
Hi, you mentioned in passing that you have to watch your code to make sure no one put a backdoor in there. Is there some special sauce you got in the cloud, or is it still tripwire, MD5 hashes, or auditing all your code?
So it's still the same kind of thing where you have to watch the integrity of the code, but the problem is that most of those tools don't work. If it's not something that's going to get tripped up by the dynamic nature of IPs changing, it's something that's going to grind your servers so much that your per hour costs are going to go through the roof. And so I'm not here necessarily to say what solutions are out there to solve. My company has some great solutions for solving these. But the problem is that traditional approaches simply need to be rethought. And that's really the challenge for all of us, is to go back and reassess, okay, we're using the cloud, we're all really happy about that. Oh, it turns out our traditional tools don't work. Now we have to rethink what to do. Who here have I at least encouraged to go back and reassess what you're doing in the cloud? Talk to folks on your teams. Couple? Okay, my job here is done. Other questions, sir? Yes, Cloud Passage? Okay, great question. So you asked Cloud Passage what we're about. So we secure servers running in the cloud. We do very much all of this. We automate host-based firewalls. We have intrusion detection, vulnerability scanning, all those things on your servers built for the cloud. Specifically, we're a team that between us have more than a century of security experience. And when we looked at the nature of this infrastructure as a service world, we stepped back and we realized that we're going to need all those security pieces, but we have to rethink the platform by which we deliver those. And so I encourage you to go check out the website. It's actually free for up to 25 servers, and you can get all the security functionality there, and it literally takes less than 5 minutes to set up. So please do check it out. Question over there.
Can you give a little bit of an insight into how you automate?
Yes. Yes. So the question was, how do you automate security in the cloud? And that's really the trick. So I'm not going to get into secret sauce on what we do, but there are a lot of tools out there that people are using for automation, for building servers, running servers, deploying software, those kinds of things. The trick is for security people to look at is what are the things that those automation tools can really automate that seem to give you security. So a lot of tools can create new firewall rules for you, for example. But those same tools are not that good about tearing down old firewall rules if a server goes away. And they're definitely not run on a real-time basis. So if you're using Chef, Puppet, those kinds of things, and you may put server groups in and say, build me an IP table rule for something like this, they are not going to go and tear down those rules in any type of a time frame that's going to keep you secure from that attack. So you need to find something out there that's going to help you do that, that's going to get the right security posture. Yes, over here. Once we'll get the mic over.
So even in the environment where you're using a gold master to go configure all the things out in the cloud, how do you handle the inevitable conflicts and control over configuration management that you've got between your DevOps people and your security people and whoever else is working on this? I mean, you've talked a little bit about it here, but it gets to be an organizational challenge as well.
Yes, more than anything, it gets to be an organizational challenge because, and this is why I believe I have a previous slide that a friend of mine, Chris Hoff, who borrowed from another book about the security sine wave of pain, and how so 10, 15 years ago, host-based security was the gold standard, but then we decided that organizational structures wanted to get the security teams out of the development team's hair, and we moved to network-based security. That works. There's a lot of things you can do on the network. We're back in a world where you're going to have to do host-based security, but we have to do it differently than we did it before. Host-based security previously was very labor-intensive, both for the security team as well as the operations team. And we have to figure out in this cloud environment, which is much more dynamic, how do we do that in a way that you can separate those security controls so that hopefully the developers don't have to realize that they are being secured, but we are watching what they're doing, we're locking down places where necessary, and we're staying out of their way. And that's a new set of tools that can help do that is, I think, what's really valuable here. So, does that answer your question? Great. Okay, cool. We have time for one more. Huh? 7 minutes. Okay, cool. Yes.
Now, actually, a question: how many, well, maybe customers have you seen actually embracing this kind of new paradigm in developing an application, where not everything is actually just on one app server, and they distribute the application over several services, which actually kind of has two effects. One effect is that they kind of widen their attack surface because more machines are up. But by distributing the important and sensitive data over several hosts, basically, it basically also makes it harder for the attacker to find the right information because it's distributed over the cluster. And if you take, for example, whatever data you name, like credit card data, for example, if you distribute it over a cluster of several databases, where only one database handles just a tiny shard of that full 60-digit number, for example, it kind of becomes more or less kind of, let's say, not impossible, but hard to actually get the data they want. And they have to kind of understand the application itself before they know how to get the data.
Okay.
Have you seen those customers yet? I've seen a few, and they're very far ahead of their time at the moment, but
right.
Nobody actually preaches and kind of educates the rest of the world about it.
So if I can paraphrase, you're wondering, is it common for people to think about essentially distributing their data and applications across multiple servers so that they're limiting their exposure on any one specific big server?
Correct.
Yes. I have, absolutely. I have seen some people doing that, but I've seen as many people not. I think that So there's a subtle question in there about risk management, which at the end of the day is what security is about, and your risk of that one individual piece of data getting compromised versus the larger set. It's a little bit of a fallacy, and I'll give you an example. This has come up a lot recently, where people may distribute their database server or their database data across multiple servers. If one gets compromised, there's only a subset of records. You only have to pull out an advertisement for 10,000 customers in the local paper that they're compromised as opposed to 100,000. But on every server, especially in the cloud, there is very often a piece of sensitive data that gives you the keys to the kingdom. Your Amazon API key is disturbingly at risk if you're using S3 for storage, for example, or something like that. And as much as you might distribute amongst servers in your cloud or distribute data in their services, there's usually that one or two golden nuggets on every single server, which is the first thing the attackers are going to look for, because that makes it a lot easier to go and get the rest of your systems, essentially. So it's an interesting idea. I think we're still in the beginning stages of cloud security. Cloud itself didn't exist 5 years ago, and the infrastructure as a service world is really very new. Many of the things we've done are the core pieces of security. There's definitely an interesting new world talking about the data and how you handle the data in the cloud, those kinds of things. So it's going to change pretty dramatically. In the meantime, I would recommend people not just look at what can I separate from my servers so that they're not at risk, but I take a broader risk management view of the world, which is what a good security person should do, and figure out what's my highest exposure, whether it's the data that may be on one server or multiple servers, or if it's that API key or those kinds of things. So, good question. And did we have any questions online or on the Twitter? Anything? Okay. So we'll wrap up. So please do, if you have questions later on, more than happy to talk online. Again, community.cloudpassage.com, Rand Wacker on Twitter. Be here all day. We've got raffle tickets and bouncy, blinky, lighty balls too. So there we go. So if you want to talk more, we're more than happy to. Thank you very much.